Okay, so we have finally reached Unit 3. We're going to do a little review of exponents. So some of you might get this and you'll be able to fly through this, and some of you might be seeing this for the first time. So let's do this quickly. All right, so here's our example. This is called an exponent. Let me change the color. This is an exponent. It's also called a power. All right, so either one may mean the same thing. The 8 is called the base because that is what is getting multiplied. So 8 to the 5th power means that we're going to write 8 5 times and we're multiplying it by itself by 5 times. So we would do 8 times 8 times 8 times 8 times 8, and that would be our answer. One thing I want to talk about is the 0 power. So if we have 5 to the first, that just means we just have a 5. 5 squared means that we have 5 times 5. And that means we would get 25, not 10. That happens a lot, especially once we start getting into the more complicated things. A lot of times people start multiplying these two. So we just got to train our brain that when we see those little exponents that we're not multiplying, we're multiplying 5 times 5 and getting 25. So 5 to the third means 5 times 5 times 5, which if you don't know that off the top of your head, you can take the previous term or basically just multiplying by 5, because now we have, here we had 2 5s, now we have 3 5s. So we're going to get 125, because 5 times 25 would give me 125. And then this would be the same thing. This would be 4 5s getting multiplied together. If I don't know what it is, I could take the previous one and just multiply this by 5 to get 625. So basically I could just keep multiplying by 5 here and here. So using that idea, if I have 5 to the 0, a lot of people think this is actually 0 because they see that 0. But that doesn't follow the pattern, because there is nothing I can multiply 0 by and get 5, which is the next part of the pattern. So if we think about it, that means that this 5 to the 0 must equal 1, because that's the only way that I can start the pattern, that if I multiply by 5, I can get to the next number. So any number to the 0 power equals 1, not 0, because that's the beginning part of that pattern of multiplying. You know, if it was 8 to the 0 and then 8 to the first and 8 to the second, it would have to be 1, and then the next time I would multiply by 8 and by 8 by 8 by 8. So any number to the 0 power equals 1, not 0. All right, so then we have some rules whenever we're multiplying exponents together. So if we're multiplying numbers that have the same base, remember the base is just 5. So if they have the same base, there's a rule that we can do. So I just want to show you real quick why the rule works. So 5 squared means that I'm multiplying 2 5s together. 5 to the 4th means that I'm multiplying 4 5s together. This sign also means I'm multiplying. So really I have 1, 2, 3, 4, 5, 6 5s getting multiplied together. So this is really 5 to the 6th. So if you look at the exponents, to combine 2 and 4 and get 6, that means we must have added these. So we add the exponents whenever we're multiplying numbers with the same base. So down here, we have a 2, all of them have the same base, so we're going to add the exponents. 3 plus 5, 5 plus 6. So 3 plus 5 is 8, 8 plus 6 is 14, so this is going to be 2 to the 14th power. All right, so we're adding exponents if they have the same base and we're multiplying them. We don't change the base. Don't change base. Right, that happens a lot. We're only adding the exponents. Now for dividing with the same base, so notice these both have 6s, let's follow the same idea. This means that we have 10 6s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the bottom, we have 6 5 times, 1, 2, 3, 4, 5. And we should know, especially after this unit that we just finished, is that if we have the same number on top and bottom, they divide to make a 1 as long as we're multiplying them. So these 6 divided by 6 is 1, so they basically cancel out. These would cancel out, these would cancel out, these would cancel out, and these would cancel out. So the only thing we have left is 1, 2, 3, 4, 5, 6s. So this would be 6 to the 5th. Now, if you look at 10 and 5, what we do with 10 and 5 to get 5, we don't divide, which is what some of you are going to do at some point. It's really 10 minus 5. So we're going to subtract the exponents, but we don't change the base. All right, so down here, we have 2 to the 8th, 2 to the 3rd. They have the same base. They both have 2. So we're going to do 8 minus 3. and that would give me 5. So it's going to be 2 to the 5th. One thing that I remember is that I use this as like the subtraction sign. So it's like 8 minus 3. Right, so whenever you see divide, it's like 8 minus 3. With that divide, so you're subtracting. So this would be 2 to the 5th. Now we have powers of powers, and what that just means is I have students that call it the double stacked one. So it's like exponents on top of exponents, powers on top of powers. When that happens, there's another rule we're going to follow, and I just want to, again, really quickly show you why it works. So 4 to the 3rd, this is actually the base of the 5. So that means that we actually have 5 4 to the 3rds. Remember, that's what an exponent means, is how many times we're multiplying it by itself. So this 5 is telling me that I have 5 groups of 4 to the 3rd. Well, then if I break each of those down, this group is saying that I have 4 times 4 times 4. This one I also have 4 times 4 times 4. This one I also have 4 times 4 times 4. This one the same thing. And the last one also has 3 4s in it. So in the end, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 4 to the 15th. And if you look at these numbers, you can see, how do we combine 3 and 5 to get 15? We multiply them. So we multiply the exponents. All right, so if they're double stacked like that, our powers to powers, we multiply the exponents. So over here, we have our base, which is 8. We don't mess with the base. We just multiply these two. 2 times 3 is 6, so it's 8 to the 6th. All right, then the last thing is multiplying with different bases. Okay, so this is the only time that we're talking about different bases today. So let's break this one down. So this means that I have 3 5s getting multiplied together, and this one means that I have 3 6s getting multiplied together. So obviously I can't count them all up because they're not the same. However, I can combine these, and I could get 5 times 6, which would give me 30. I can multiply these two, 5 times 6, which would give me 30. And I can multiply the last two, which would get me 30. So then I would have 3 30s. So this is going to be 30 to the 3rd. Right? Because I can put each one of these together. So obviously I can't have one that has 5 to the 3rd and this one have 6 to the 4th, because then this guy wouldn't have a partner to multiply to make a 30. So I can't do that. So they have to have the same exponent. So if they have different bases, they have to have the same exponent. So must have same exponent. So as long as they have the same exponent, then you just multiply the bases. So we multiply 5 times 6. That's how we got the 30. And then we just leave the exponent. So multiply bases, same exponent. All right, so this time we're not doing anything to the exponent, we're only doing to the bases, and that's only if they have different bases. So down here for our second practice problem, we see they both have the same exponent, but they have different bases. So we just multiply the bases. 2 times 8 would give me 16, and then we keep the same exponent. Okay, so now you can hopefully remember these, and if you haven't already done your Schoology assignment, then you can go do that, and we'll start moving on to Unit 3 the next time you're in Algebra 2 class.